So let's see. Negative 1 times 4 is negative 4. Add. Multiply. Add. This is neat. I didn't mean for this to happen, but oh well. Multiply. Add. It's almost unheard of to have something going evenly, just making shit up. I can't take credit for that. But again, if I do this, you'll start to see the connections between this. So this is 4x cubed plus 4x squared. Change the sign. There's negative 11 minus 4. Where'd that negative 4 come from? This is the part that I'm really interested in. I don't care about this shit really because it's always going to be the same as that. So why would I need to keep track of it? Where did this negative 4 come from? 4 times negative 1. 4 times negative 1. Bam. I mean, so we just noticed what the important steps were and then consolidated them into a short, quick process. What is it on us to do then? We got to make sure that this is right. It's linear. It's got a 1 in the front so that the hardwired process works. And then we have to know how to interpret this. So I have some poor people that are just adding these together. No, they're not like terms. Every single one of these is 1x down. Right? What's this going to be? 4. Why? Because that divided by x is x squared, right? And this can be minus 15x plus 5. And then it would be like plus 0 over x plus 1. But that's 0 anyway. It went in evenly, which is kind of freaking me out. But I should play the lottery today. All right. Is that cool?
Yeah.
Okay. All right. Anything else from the quiz? Or yeah.
I feel like I was overthinking this. It's 2y squared minus y minus 6. I think it's different numbers.
Well, yeah.
I don't know how I just, I don't know why I put it that way.
Let's see. I don't want to do that one because there's 4 different versions of the quiz out there. So I don't want to do one version. That wouldn't be fair. Let me see. So what about what you got, Jeff? Let's do.
I think it was just like the negative y in the middle that threw me off, probably.
Sure. Okay. I think this will work. Let's find out. Yeah, well, it'll work. So the steps don't care. The steps don't care that there's this in the middle. It doesn't care. What number is in front of the x? Negative 1. So what's the first thing you do? If you want to do it the way I showed you, right? Yeah, multiply. 2 times negative 10. With factors in negative 20 had to be negative 1. They're going to have to be 1 apart, right? Yeah, 4, negative 5. So, I mean, the process doesn't change. If it's factorable like this, then this will work, period. The process doesn't care. We just have to realize it is a negative 1 that's there. It's just a number, like any other number. It's the number that we don't write. That's why it's weird, but we know it's there. So that's what that is. And now what do I do with those two numbers?
2x plus 4x.
2x squared.
Plus 4x minus 5x.
Yeah, I would rather put the minus 5x there. And then you group, right? If I have the option, I'd rather make that plus. It's not wrong to do it the other way.
Okay, I can do it from there. I didn't know I could add an x to the 5 and 4.
Yeah, it's not. We're not even adding an x. What you really have a problem with is I didn't know we could take the x away. To be honest, and one of my colleagues, they do this. 2x squared times negative 10 is negative 20x squared, and then they put the x's here. I don't know if that's better. Me, I like to focus on. Well, if that's better. Do it that way. I just like to make you realize it's sort of like synthetic division. All I care about are the coefficients. But they are coefficients of what? Of whatever the hell that is. If you put a 5 and a 4, they can't make negative x. Because they don't have any x's. How could they make negative x? They have to be coefficients of x to make it x. Cool, I like it. Yeah?
Do you have my quiz?
Yep. No, I sold it.
Oh.
There's a market for everything. Let's see.
Thank you.
Sure. You like my shirt? I wore it last semester and all that. Some students got upset. I'm like, well, you probably ones aren't going to pass. This is not about you passing the class. You should get this today now, right? We talked about this yesterday. It's a math joke. It's not me saying, no.
That's the vertical line test, right?
Well, no, it's an asymptote. I want to call it a Gandasymptote. All right, maybe not. That's a little too far, Jeff. Oh well. It's already been gone there. It is a reach. Anything else specific from the quiz or from whatever I'm gonna? Okay.
We're gonna review the practice test. Right?
Say again? What?
We're gonna review it.
Yeah, I've got the answer key.
Oh.
Yep. Yeah.
Yeah, on the quiz, number 3B, I know I simplified it after it, but I was like, I don't know which one to have done, so I thought that would be the simplified answer.
Oh, shit. So two things. I want you to, all right, so let's do a cubes real quick, and then I'll show you. So if I had 125 m cubed minus 8, let's say plus 8, why not? How do I factor this bad boy?
So it'll be a big group.
Yeah, because it's obviously a cube, so there's no GCF, right?
5M and 2.
Yeah, so it'd be 5m, 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 2, 2, 2.
Or one of each of the little.
Yeah, 5m
Plus 2.
plus, I like it, 2.
Minor modifiers.
Yeah, 25m squared. At the end will be plus 4, and the middle's going to be, minus 10m. Now, real quick, do you see why somebody might believe? Remember what I told you about the big dude? I told you the big dude can't be factored unless there's a GCF we forgot. And there's no GCF we forgot, right? You can't factor this. So if you think it's 5m minus 2, 5m minus 2, let's see why that's wrong. You see why somebody might believe that, right? It's easy to see why somebody might believe it. But don't you get negative 10m, negative 10m, negative 20m? This middle guy is always half of what it needs to become this. Always. Is it really, really that important to realize that? No, it really, really isn't. But, it's always half of what it needs to be able to be factored, so it can never be factored unless there's a GCF we left. I like it. Sweet.
So if it was like 25m squared minus 10m plus 5, you could factor out a 5 on that.
Yeah, you can take a 5 out. Yeah, exactly. Cool, I like it. So you can never factor the big dude, basically, because even the GCF thing I keep bringing up, it would show up here, really, if you left it in. So for example, what do I mean? So it's like 64x cubed minus 8. Is there a GCF?
Yeah.
Yes. Even if you didn't take it out, is it still a cubes?
Yeah.
Yes, because that's 4, so 4x, 4x, 4x. 2, 2, 2. So this would be 4x minus 2.
Would it be cubed?
No, one of each in the little dude.
On the same side.
And then 16x squared at the end would be plus 4. And then the middle would be plus 8x. And do you see how there's a GCF in both of these?
Yeah.
Yeah. So the only way you could factor the big dude is if there's some GCF you didn't take out in the first place. The only way. You can never break the big dude up like this. Never. Never, ever, because this is half of what it would need to be.
So how would you take another GCF out of the little dude, big dude?
Well, now what comes out of here?
2.
2. And I'm left with 2x minus 1. And what comes out of here?
4.
4. So I'm left with 4x squared plus 2x plus 1, right?
Does that only work with difference of cubes? Most likely.
Does what only work?
The 64x cubed minus 8, that
If this would have been a plus,
another factor of difference.
if this would have been a plus, this would have been a plus, this would have been a minus, everything else I did would have been the same.
Okay.
Right? That's the only effect that a difference or sum has.
If it only has a GCF, right?
Okay. The only weird thing about this problem is that there was a GCF I could have taken out. Either I take it out now, or I take it out at the end. Right? If I would have taken it out at the beginning, then this whole thing would have been easier from the beginning. You see 2x, 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 2x minus 1. The other 2 x's, two x's, the other 2 1's, and then 2x times 1 is 2x. I mean, if I take the GCF out of the way, my numbers are smaller. It's easier to work with. But the math is like, take the GCF out whenever the hell you want to. I'd rather take it out at the beginning. All right. I like it. Yes?
So even though I hadn't done the work, I didn't realize I could get back to it.
Yeah, you can't. So you should have stopped. Yeah, that's the suckiest mistake to make is, I'm not picking on you because other people did stuff similar, is to get the right answer and then go one more step when I'm like, oh man, shit. And normally it's like people putting stuff together that's not really like terms or something.
I have a question from the online homework.
Okay.
Question number 19 from 8.2.
Oh yeah, I remember that. No, I don't. That's what other people like. What? No, my memory's nowhere near.
Says if the graph of a linear function f passes through -2 and -1, and then the other points are 18 and 7.
Graph of the linear function passes through those 2 points. Oh, okay. If I want you to find, so what's the points? -2, -1?
Yeah,
And
18 and 7.
18, 7? And what 2 things do I need for the equation of a line? Slope and y-intercept, or slope and point at least, right? So if I can use this formula here, right? Now don't freak out. I know you're like, but it's got f of x shit in there, Jeff. Jeff doesn't care. Jeff says you solve. All right, Jeff. Sometimes that's not even Jeff. Y equals blah blah blah, right? You plug shit in, you get to y equals blah blah blah, and what do you replace y with? F of x, because they're the same thing. They're interchangeable. F of x just makes it easier to have an f function and a g function. This would be several y functions, so it'd be really hard for me to say which one to use. If I use f of x instead of y, it's easier to say which one to use. And I also keep track of what I plugged in. F of 2, f of 3, f of 4. Here there's nowhere for me to put that shit. So y is f of x, right? I don't know if that's part of what's... So the wording they're using, the Tauchian function notation, but you notice the whole thing is find the equation of this line. That's the kind of problem it is. Yeah, so we need slope. We need a point. I've got 2. You can pick one. I would probably pick that one. Right?
So it doesn't matter which one.
It doesn't matter. If you do it correctly, you'll come out with the same answer both ways. That shouldn't surprise us because the line has an infinite number of points. It shouldn't matter which point you pick to get its equation. Yeah.
So the first equation there, y minus y1, that's how to find its slope, the one below it.
No.
You would use a point.
Slope is this dude.
Intercept.
This equation for a line came from the equation for slope. This is the equation for slope. I'm given 2 specific points. This is the equation of a line. Y and x are allowed to be any point on the line they want to be, not a specific point. So I find a slope. I pick a point. I plug that there. I plug this here. And then I simplify it. Yeah, we've done that whole process before. Right. Cool. I like it. See some of you thinking, man, those people are probably at the beach or something.
What if the function gives you the equation of the line, you're supposed to find the points of the slope? It's like a reverse action? Or if they had the function of the
So I've done that to you too. I give you something like 4x minus 3y equals 12, and I say find the slope and the y-intercept. Is that what you mean?
Well, if it's, say the question says, function of the given equation of a line is this, what is the intercept and the slope?
Yeah, exactly. All right.
It's just like...
Well, if they give it to you as a function, what's really funny is that it has to already be in mx plus b form, because they've already solved it for
That's
y.
what I was thinking, yeah.
So if they give you, this function represents a line, what's the slope and y-intercept? Hey, kick ass.
Right.
So really, something, if they give you a function, they've already solved for y, because that's what f of x is.
Okay.
And in terms of lines, that kicks ass. Because that's normally what I have to do is solve for y. If they give it to me and then, oh, thanks, you did some work for me. Shit, yeah, I can just see the slope and the y-intercept.
Okay.
Yeah. Maybe. Okay. All right, where do you want to go from there? Let's see. Anything else from homework stuff before I get into the last section of 8? Okay. All right. Let me fire this dude up because I want to show you something on here. Eventually. Whoa. Where's my good eraser? There it is. Okay. So we got a little tiny bit into this last time about absolute values and how they work in equations. So remind me how this simple equation works first. Okay.
Absolute value of x
Yeah.
equals
So if you haven't, in fact, it's almost better if you haven't like memorized anything. Just think about what makes sense here. If I pick a value, where am I going to put it? If I pick a value for x, where am I going to put it? In absolute values, right? So you can actually do this without, you feel like you're not really doing any math. Just think, what would I put inside? What would I put inside here so that the answer would be 11? 11.
Or negative 11.
Or negative 11.
Yeah.
So whatever is in here, if it's x, x has to be 11 or negative 11. Period. Right? Whatever is in here. So what if there was a y in here?
y has to be
Then y has to be
11 or 11.
11 or negative 11. Right? I like it. What if there was a x plus 1 in here? Keep it going. Then, no, don't go too far. Just go to the next step.
It'd be
Then x plus 1 has to be 11. Or x plus 1 has to be negative 11. All right. Because what is x plus 1? It's a number. So what's this equation really asking me? What's this number have to be so that this is true? That's really what this is saying. This is the first equation. We have to look at it like this. And then you can make the process. You can memorize the process. But try to remember why the process works. Whatever the shit's going to be in here, it's got to make 11. And there's only two things that can make 11 in an absolute value. 11, negative 11. So then I say, I'm going to force the number to be 11 so I can figure out what x is to make it happen. And like you said, 10. I'm going to force x plus 1 to be negative 11, and then I'm going to see what x makes that happen. X is negative 12. Now, real quick, I want to show you something. That's the math of it. I want to show you something that's not useful for solving these things. That's why I like to do one algebraically real quick first. Because you know very quickly it's going to get disgusting in here and more shit's going to be outside. You know it's not going to be like this. Right? And not just because math people want to make your life hard, but because this stuff is useful. Depending on where you go, you're going to have things happen like this. And I don't mean you're going to go to the store and buy lettuce and you have to be able to solve that. But I love that shit. Where was I going to go? Oh. So looking at this real quick. Let's look at this more closely. Remind me, what does this absolute value actually mean? Let me do it differently. What does this absolute value really mean?
The distance from 0? Or
Distance. Distance between what in this case? The distance between a number and 2. Must be 5. Let's see visually why I should expect to get 2 answers. So here's 5. Flop. All right, let me not put 5 in. Here's 2. I want to find the numbers, or a number that is 5 away from 2. Let me say this again. What does absolute value mean? Distance between things, right? Absolute value of 4 is the distance between 4 and 0. Is you guys with me? Because what doesn't show up is this. the distance between 4 and 0. Right? You guys with me a little bit? So in general, if I said, what's the distance between 5 and 11? Well, the answer isn't -6, right? The distance between 5 and 11 is 6. Well, 5 minus 11 is -6, but the absolute value is 6. So absolute value just makes sure it's a distance. Negative distance doesn't make sense. You're 0 and now you're negative. What does that mean? All right, so what's 5 away from 2? 7. 7. What's 5 away from 2 the other way? 1, 2, 3, 4. -3. So I should expect 2 answers because I have 2 directions to go. And I let that sink in. I mean, that is always in the background. Even when things get more disgusting, it's not nearly as easy to interpret it on a number line, but that's still basically why I should expect 2 answers for a lot of these. So if I do the math behind it, what's the algebra say I do? Either x minus 2 is 5, or x minus 2 is -5. So sure enough, I add 2, I get 7. I add 2, I get -3. So of course the algebra picks this up again because they represent the same thing. But algebra helps us when I got more shit going on here and I can't do it like this. I can't quite see it this way. Have you guys ever seen that before about really interpreting what that is? Some of you guys have. Some of you guys are like, I've never seen absolute values in equations. I wish you'd stop doing that. But too bad. All right, let's try one that's a little more disgusting then. A little bit. I think we did one of these yesterday. Maybe it wasn't quite this gross. Oh, cricket's still there. Ooh, let me do this. Why? Because I don't want something to happen yet. So equal that, change that to a 3 on that side. All right, now do you notice, now you start, and when you look at this, there's a couple different ways to look at it, so we believe in the algebra a little bit more, because this is the one we just got from freaking the idea. What's 5 away from 2? Well, I know, and then the algebra goes, hey, I got it too. Okay, algebra, maybe you're onto something here, right? This, can you do this? No. You could, but it would be a real stretch. It would be really freaky looking. What's the difference, though? Why? That looks more disgusting. This was easy, algebraically and visually, but at least algebraically is really easy. So what's the difference between how they look that I should expect it won't be that easy? I've got to do something first. Hopefully this makes some sense here. What do I have to get by itself first? What's by itself here? The absolute value piece equals a number. Then I can write my 2 cases. Well, that's not what that looks like yet, so what's the first thing I should do? I want to get what by itself? I want to get this by itself. So what do I do first?
You take 5 away.
Yes, take 5 away. I love it. Don't do 5 minus 2. We should be past that. It's PEMDAS violation. That's bad. Right? Subtract 5, subtract 5. Yep, divide by -2. So you get 11 minus 3x equals 1. Not yet. Yeah. So why did I do all that? Just so I can make it look like this, because if it looks like this, I know exactly what to do algebraically. That's all. So we do this all the time. We isolate where our variable is first. You should be used to some phrase like that. You isolate where the variable is first. Well, that's exactly what we're doing. Now I can write either what? 11 minus 3. So the number that's inside has to be 1, or the number on the inside has to be -1. That's the idea of absolute value. 2 inputs could have the same output. So now you subtract 11 Divide by negative 3. All right, now this should be the easy step. All right. Subtract 11, divide by... Cool.
You just said that there's two inputs get one output already.
Yes. So if that input number, this number is 1, then the output's 1. If the number is negative 1, the output's 1. Yep.
Oh, like a couple sections back, you're talking about domain and range, two inputs out.
Yeah, so that's allowed for a function, right?
Right.
And real quick, the fact that like a parabola, an absolute value does this, then they could have, if you look at an output of 4 and you look across, doesn't it hit it twice? So there could be two different inputs that have the same output because it kind of goes back on itself this way. All right, that's a little more than it had to do there.
Well, that's true, right? 4, negative 4. Or the other side, the alpha could hit 4, negative 4, like that.
Exactly. Yeah. 2 squared is 4. Negative 2 squared is 4. I like it. So same in two different inputs can have the same output. Okay, cool. I like it. So if you don't enjoy me trying to explain all the shit behind the scenes, at the very least, get the absolute value by itself, then you get 2 cases. You can kind of memorize that. That's fine. Okay. So let's look at something a little funkier.
So 5x minus plus 1.
It's a 3. Well, I mean, you can't subtract 2. It wouldn't do anything. Because it's subtraction, not the opposite of what's happening. You got to divide. I like it. So whatever you do, it's always got to be the opposite of what's going on.
Do they also function as like parentheses? Like,
I love it. Absolute values are in the same place
okay.
in the
so
order of
I should do them
operations.
first.
You have to do inside first if you can, but we can't.
Okay.
Which is why we do this 2-case thing to get around that. Now what?
Write it algebraically is.
We could. We totally could. But that would be more work than we should have to do. And as a student, I understand this. You get so caught up in what's the right steps, and then you forget to realize that math actually makes sense. It actually makes physical sense. This equation has no solution, right? Why?
Oh, it's absolute value.
Absolute value can't be negative number. So remember, we talked about this the other day. If you do this, if you write your 2 cases, you will get 2 answers, and then neither one of them is going to work because, right? There's no answer to this. So if I write 3x plus 1, it has to be negative 5, or 3x plus 1 has to be 5. Well, that doesn't make any sense in its own. If that's 5, what's the absolute value of 5? Not negative 5, right? So these 2 cases were written illegally. They don't come from this statement. But again, you feel like you're doing this process, right? Yes, this is why people that only memorize processes make silly mistakes like this, because they don't realize what's happening, what should make sense. This doesn't make sense. And then you subtract 1 divided by 3, subtract 1 divided by 3, you get 2 answers, and neither one of them worked because everything you did was bogus. So you got to look for this, so you don't go further, right? Stop right there. Some of you guys feel like, well, he says he's all about showing work and oh shit. Well, no, just say, bam, no solution, bam. That's your work. That's all the work I want to see on that one. Sometimes showing too much work is bad because you should just be able to tell some things. Yes?
So if it was a negative 2, you could solve it at the very beginning?
Yeah. If that would have been a negative 2, sort of like what happened over there.
Yeah.
Then when you divide by negative, that becomes positive 5. Now you can do it. So I'm glad you asked the question. Don't stop at the beginning. You got to get the absolute value by itself to see if this is negative or positive. Don't go, well, there's a negative there, so I can't. Well, maybe that's a negative and they'll cancel. I don't know yet. So you got to get the absolute value by itself first before you can see if you stop. I like it. Okay. You guys look unamused. Okay. Blah, blah, blah. Okay. So that's basically everything you're going to see. Oh, there's one more thing. One more kind of problem you'll see. This one always freaks people out. Let me ask you this. What would I put in here to make this statement true?
3 or -3.
Three.
I like that. It's keeping track of all the guesses. Yeah, 3 or -3. Both sides have absolute values, but how many cases did we still have? Just 2. 3 or -3, right? So, you might have something like this. Here's where things get interesting. Let's see if you can handle this. All right, here we go. Watch this. This is where you start to really feel out what's happening here. So what's got to be true? Either 5 minus 2m is 3m plus 2. Is that cool? If that number was equal to that number, then obviously this works. It's like putting a -3 in there. All right, make the number the same. It's going to work. Because I made both sides exactly the same, right? Now here's where I got to get you guys to go with me. Or 5 minus 2m, either this number is the same as that number or this number is the opposite of that number. So, or this number is the opposite of that number. It's really the exact same thing we've been doing. It's just that now in this problem they have unknown numbers on both sides. But you still say that number equals that number, or that number is the opposite of that number. And now you just solve both of those equations. That should be the easy step. You guys really like that one. So add 2m, subtract 2, you get 3 equals 5m. I get m equals 3/5. This one I got to take that negative through. Let's see, add 3m, I get m. Subtract 5, I get -7.
Those aren't the same.
What do you mean?
They're not equal to each other, are they?
I don't care. They don't have to be. Watch. Again, remind me. Either that number is this number, or that number is the opposite of this number, right? Then that makes that true, right? So that m makes these the same number. That m makes these negatives of each other. That's it. You're all like, stop it. Why are you doing this? Come on now, you guys can do this. You guys can make it. You guys can make it. It's really, when we solved that earlier one, we didn't get the same numbers at the end, did we? No, of course we didn't, because in one case I wanted it to equal a positive number, and the next case I wanted it to equal a negative number. And I just solve for what variables make that happen, what values make that happen. There is nothing here to just look at this and make sure you get the right answer. There's no way in hell. Why do you think somebody might throw this one out? Yeah, because they get way too freaky about the negative. I can plug negatives in to an absolute value. No problem. Right? So getting an answer that's negative here, not a problem, because that's what I'm plugging in. If I have an absolute value equal to a negative number, well, that's it. Okay. Let me show you one more like this, because it's where you get possibility of just one answer or an infinite number of answers or something. Let me show you. Right, so take a minute and try to set that up. Remember, it's absolute values there. It's got to be 2 cases. So what's case 1?
M minus 7 equals 5 minus 7.
Yeah, so the first case pretty much is always leave everything alone. Just take the absolute values away. That's a case. If everything's already equal, then absolute valuing them, they're going to still be equal. That kind of makes sense. Or,
M minus 7 is all 5 minus 7.
yeah, good. Once you distribute, I like it. Cool. So obviously you could skip that step if you just see you got to bring the negative through. So here I'm going to add m to m. I'm going to add 7, get 12. M is 6. Yay. What happens when we try to get our other answer?
Negative 7 equals negative 5.
Yeah, negative 7 equals negative 5, because when you subtract m, the m's go away. That's why I love you guys. I hate variables, but then when they're about to die, you try to save them. Oh, man, it's such a weird, you suck, oh, wait up. Right? Let him die. He's been around for a long time. He's going to just pass away. What does this mean?
It's not
It's not a solution.
a solution.
No solution. Does that mean there's no answer to the whole thing?
No.
That case doesn't have an answer, but the answer to this question is that. There just happens to be one answer only.
It only equals 6, right? It wouldn't be 6 or negative 6, it's just 6.
Yeah, don't put stuff on top of this. The only way you would have two answers if each case came out with an answer. Right? People start to and I don't blame you. You're all like, get off my case, but I'm not on your case. You start to think, I haven't got covered my ass with everything. This is an equation I wrote based on an idea. The answers to this equation are at least part of the answer to this problem. You don't have to do anything to this answer. Right? It came from this. You don't have to put a plus or minus on it. It is just part of the answer. And then we go over here and we're like, oh, there is no other part of the answer, so that's the only answer. Yeah. I like it.
Will it ever come down to like both being on a solution? Or is there any way that
yeah. It would be a little bit
something out early?
worse. Yeah. I'm going to show you, in a minute, I'm going to show you some stuff in the graphic out. I'm going to show you a way, and people get a little too excited when I show them this, of how to solve any equation just by graphing it and seeing where something happens. And that's it. So you can solve any equation. It's crazy. Okay. So the next level to this is bringing in inequalities. And this is where I said, I gave you a little teaser that it helped with sandwiches. We were talking about sandwiches. It helped with restraining orders. So, the absolute value inequalities. So let's just analyze the most basic possible situation, right? So this says the distance away from 0 has to be less than or equal to 4. What's an English phrase instead of saying less than or equal? Like you have to be less than or equal to 12 to eat off the kids' menu at Denny's. So you have to be at most 12. So in English, this is saying the distance from 0 to this number has to be at most 4. Now think about that. So here's 0. I only want to get at most 4 away from 0. So this, I always call this is like the sandwich, but it's also you're about to go into a haunted house or something. You're not dumb. You're going to split up and do that weird shit. You're going to like, stick close to me. Holy shit. Within the realm of the candlelight, right? If it's 4 feet radius, I don't want you to get further than that away from me. I want you to stay close. Sandwich, right? So what's the furthest this way I can go? That's crazy. What's the furthest that way I can go? That's crazy. And what do I put on those? Bracket. Sandwich. Stay close. Here I am. I don't want you to get further away. That further away, that further away. You with me? I like it. So if we're in this really narrow hallway, I want you to be 4 feet in front of me or 4 feet behind me, right? Not further than that, because then I can't see you. You can't see me, and it's weird. Okay, maybe. Is that cool? So, what must greater than mean? So I want the absolute value. I want the distance from 0 to some number to be more than, let's say, 3. So I don't want something to get closer to me than 3. So what's the closest in this? If he's up way up here, like at 27, that's fine, right? Is that cool?
Yeah.
So what's the closest it can get to me? Almost 3, right? And I don't even want to include 3 here, do I? So he could be up here anywhere, right? Right, here's fine. You know, here's a little, hey, how you doing, man? Hey, what's going on? Here, danger. No. Screw it. You've violated the restraining order. Right? Stay the hell away from me. So on this side, again, he's walking. How close can he get to me? Negative. So you see how visually it is what I keep doing? This. Do you guys see that? Stay away from me. Right? This is not the haunted house. This is completely the opposite. This is like the creatures in the haunted house. You want them to stay away from me. Right? Okay. Again, I love it. Just 0 reaction. Okay. Does it make sense is what I'm hoping. Or are you just dealing with my weird ways of putting situations together? I don't know. How do I write this in interval notation?
Negative.
Yeah, negative infinity.
Comma, -3.
And then the same symbol.
It's done upside down U.
Or just a U.
Split with the upside.
Because that would be intersection, and there is no intersection between them. Yeah, so I want this one or. Do you guys? I really want you guys to realize, if that would have been a less than, it would have been the sandwich that I left out right now. So they are opposites of each other, of course, right? The less than or equal to is the opposite of the greater than. So the sandwich that the less than or equal to would be is this in the middle that this says I don't want it to be that. I don't want it to be everything else away from there. They're opposites. We know they're opposites. So visually it should be opposite. So if this would have been that, let me just say that, just to make it, then the answer would have been this stuff on the inside, right? Stay this close to me. They're opposites. So together they should make the whole thing. Right? Okay, maybe. So of course, hopefully you guys realize it's the same idea of what we did before with the equations. They're not going to start with absolute value of x, right? They're going to start with 7 plus 3 times 4 minus 5x is greater than what, Jeff? It doesn't really matter. All right, then. It's greater than, you just said it didn't matter. I know. It's greater than 12.
Subtract 7.
Ooh, that made this really gross. Oh, well, too bad for all of us.
Subtract 7.
Yeah, subtract 7. Divide by 3. You want to isolate the absolute value so you make it look a lot more like those. So divide by 3. You guys are going to love this. Now here comes the kicker. What are the 2 cases I can write? Well, look at this real quick. Let me take this guy out of here. Let's investigate this greater than. What are the 2 cases? Either, like this one. What would you say this one says? Algebraically, what would I write for this alone? X is greater than 3. Or X is less than negative 3. So the inside's got to be bigger than 3, or the inside's got to be less than negative 3. So think about it. Why does that make sense? What if it's negative 11? Well, it's the absolute value of negative 11, and that's bigger than 3. But if I try a negative 2, that's not relatively big enough so that when I take the negative off, it's still bigger than 3. That's the idea. So here, I got a greater than. Greater than is going to be an or. Because it's a stay away from me. It's this or that. Right? Do you remember the sandwich then is going to be an and. A less than is going to be an and. Stay close to me. So it's going to be 4 minus 5x is greater than 5/3. Let me see if you guys can tie in. For the second case, what's got to change?
Negative 5/3.
And when I do a negative to an inequality, what else changes?
It swaps.
Yeah, so you see how that's x greater than 3 or x less than negative 3?
Because you're pretty much multiplying it by -1.
Exactly.
Okay.
I like it. You really are. There's a whole other way to kind of do this, but it would make that piece make sense, but a lot of the other shit wouldn't make sense then. So I choose to do this one. Or 4 minus 5, get out of there. 4 minus 5x is less than negative 5/3. So it feels like the equations we just did. There's two cases. You still make that the same or you make it negative. But because it's an inequality now, I've actually got to show that it switches the sign. And then you just solve each one of these. Right? Now on this one, it's beautiful fractions. We all love those. But, come on. So solve these. Or little fractions. The hardest step should be where you have to divide by -5. But even then, I want you to realize, dividing by -5 is multiplying by -1/5. And I can always use fractional rules when I have fractions hanging out. Don't put the whole thing over -5 and freak out. So if I subtract 4, I've got to make it multiply by 3. So 5 minus 12. -7/3. Okay. And then I multiply by -1/5. I multiply by -1/5. There's a couple things going on there. So get x less than, because I multiply by negative, less than 7/15. Or subtract 4, multiply by 3. You get -5x less than -5 minus 12. -5 minus 12. -17/3. Then you multiply by -1/5 again, right? So you get x greater than, positive 17/15. So when you go to graph this, here's the beautiful thing. You slap a 7/15 and you slap a 17/15. Please make sure they're in the right place relative to each other. Sometimes people just throw them down there. Less than 7/15, so I put parenthesis, or greater than 17/15, again, parenthesis can go that way. And there's my stay the hell away from me idea. All right? Yes?
How'd you get -7/3?
Oh, so 5/3 minus 12/3, I had to make the -4/1 have an LCD, of course, right? And you always do that. Always. What's 8 minus 5? why don't you just go ahead and subtract them? Because they already have the LCD. They already have 1s. So it's just if they happen to show that they don't have a 1 on the bottom and something else has a 1 or something, you need an LCD. You always need an LCD. Okay. Yes?
You only need an LCD when you're subtracting fractions, right? Or when you multiply, you see the multiplication part of the fraction.
Oh yeah, and when you multiply, divide, just like we did here. Because the whole idea of multiplying, dividing is reducing. So why would I build stuff up if I really am just trying to reduce everything?
You could like cross cancel those fractions had they.
Yeah, exactly.
Matched
They
up
just,
that
yeah,
way.
exactly.
Yeah.
They just didn't have anything. Yeah, I like it. Yeah, that would have been a 20. I could have canceled the 5. Totally. Now the other one is kind of nifty. Remember this one we had earlier, and it was this. How would you write this algebraically? -4.
Bracket.
Not interval notation. Algebraically. -4. Where's x's? In here. So -4 is less than or equal to x, which is less than or equal to 4. That's what sandwich looks like in pure algebra, right? The answers are sandwiched between -4 and 4. Less than or equal to will always be written like this. So let's do an example like that, and then I have a handout so I can finally shut up and just let you guys try some on your own. So we got this here. I keep using it, I don't like it. Go away. So what if I had this here? Oh, what you got, Jeff? Let's say 10. So what do I need to do very first thing? Yeah, isolate the absolute value. So add 1, 2 plus 3x less than 11. Now watch, and here's how you can write this. It's the best way to rewrite this. You could, now real quick, I just want to show you, I'm going to show you this once. It kind of hurts me to write this, but you could do it this way. And then I want to show you the better way to do this. I could do my two cases separate. So either 2 plus 3x itself is already less than 11, right? The thing that's really weird is, it's a lesson that's going to be an and. 2 plus 3x is greater than negative 11. Now watch. Let me read this off to you. What does this say? It says negative 11 is less than this.